All right, so when I was doing all these labs, I did the dissolved oxygen one, and it decided that it didn't want to upload. So came back up here to do it again. So this is take 2 for dissolved oxygen. All right, so we have a sample here that does not have any air bubbles in it. This one's got a little air bubble in it. So we're going to use this one. And hopefully it's going to be the last time that we have to do it. Okay, so I got my DO test kit right here, and my instructions right here, so I'll just read them out as I perform the test. It says, rinse the water sampling bottle out with the sample water. All right, so this water sampling bottle is rinsed out. It's good to go. Then I have to fill the bottle with the sample water. We got to be real careful to not add any extra oxygen in that by making this bubble or anything like that. So I got to make sure that it's completely filled up to the top and it does not have any air bubbles in it whatsoever. I overfill it even more, and then I take the cap, wherever I did with the cap, I twist it on. Alright, so no air bubbles at all. So that's a good thing. Put this over to the side here. Now I have to add the reagents. So it says immediately add 8 drops of manganese sulfate solution and 8 drops of alkaline potassium iodide azide. All right, so I'm gonna go ahead and safety goggles up here. So I need manganese sulfate, which is here, and alkaline potassium iodide azide. So 8 drops each of these things. So one, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. Cap the bottle and mix by inverting several times. Okay, cap the bottle and invert several times. It says a precipitate will settle or will form, and I'll have to wait until that precipitate settles and collects down here below the shoulder of the bottle. Okay, so that's mixed pretty good. So we'll just let it sit there and let that settle. In the meantime, I'm going to go ahead and I'm going to prepare my titration solution. So that is going to be there. And I have to take my plunger and I have to fill it up with sodium thiosulfate. So here's the sodium thiosulfate, just like medicine. I gotta go to the 0 line, and there's the 0 line right there. Put that back in its holder. Don't need that guy anymore. Don't need these anymore. Alright, so all we're doing is waiting on this to settle down And you can tell that it is starting to settle. There's still a little bit of precipitate in the top part of the bottle, but we'll give that another minute. All right, so that's pretty good. So the next thing I want to do is I want to add another 8 drops of sulfuric acid. And so once I do this and mix this, what we're attempting to do here is to fix the oxygen in this bottle. That means that any air bubbles that form won't affect the outcome of the dissolved oxygen test. So anything from the atmosphere or any air bubbles from shaking or anything like that is not going to affect it. So 8 drops of here. 1, 2, 3, 4, 5, 6, 7, 8. You see something happening in there, some reaction. So I'm going to again cap. And gently mix. So now I have to make sure that these golden sparkly flakes dissolve. And so this is going to take just a minute to do this, but once they dissolve, then everything's going to be fixed, and I get that golden color that it's asking for, and that's what we're expecting. Okay, so I'm going to mix this until it dissolves. All right, so that looks like it's pretty dissolved. And it's the color that we're looking for. So we'll move on to the titration part. It says fill the titration tube to the 20 milliliter line with a fixed sample. So here's our fixed sample, and I'm just going to pour this in there until it gets to the 20 milliliter line. Again, I don't have to worry about the air bubbles forming. Well, that's perfect. Okay, so I'm going to just leave this here for a second. And then I have to titrate it just a little bit. So what I'm going to do is I'm going to take some of this sodium thiosulfate solution, this stuff that's in my syringe titrator, and I'm just going to put in a little bit at a time until this golden color turns to a pale yellow color. So I'm going to just a few drops at a time, and I'm just going to take it, I'm going to swirl it around. That didn't do a whole lot, so I'll do it a couple more times. I can tell the color just changed just a little bit, but it's still golden. There we go. There, it started to go a little bit paler, but we'll go a little bit more. This part is not exact. I'd still call that just slightly golden, but we're gonna, there we go. I'd say that that would be good in pale yellow. Maybe that much. Okay, so there we go. Call that pale yellow as opposed to what you saw a second ago. All right, so we're gonna move all this. Okay, keep that the same, all right? Don't expel any more of that out. And then I'm going to need, at this point, I'm going to need 8 drops of starch indicator. So this is going to turn the whole solution purple or blue. So 8 drops. You can't see that. There we go. So you can look at to watch it turn blue. Eight drops. need that anymore. Put this in and we'll mix it just a little bit more. There we go. Swirling it around. Put this back in, and now I'm going to titrate until this purple color goes away. Just a little bit at a time. I didn't do much. So that one I can tell lightened it up a little bit. I don't know if you can tell on the video if it did that or not, but just a couple drops at a time. Swirl. That did something. So now it's still blue, but maybe a drop, maybe 2 drops at a time. See what that does. Clear. So it went from blue to clear. And I am at, looks like 6.8 on the graduation line there. I don't know if you can see that or not, but 6.8 or so. Before I think I got 6.4, so I'm real close. Oh, no, wait a minute. That's 5 point. No, I'm right. That's 6.8. It was right there. Yeah, I'm looking at the right thing. So 6.8. Earlier I got 6.4 when I did it the first time. So I'm within, what, 0.4 of a parts per million. So that's pretty good. So we'll call this 6.8. 6.8 parts per million or milligrams per liter of oxygen. All right. Something that's real important that we have to do at this point is take a temperature reading of our sample. And that is because that the oxygen saturation depends on the temperature. And I'm getting a reading of 19.4 Celsius. I don't know if you can see that. 19.4 Celsius. So we can say that at 19.4 degrees Celsius, the oxygen, the amount of dissolved oxygen in our sample was 6.8 parts per million. And that way we can read a graph to find the percent oxygen saturation. So that is dissolved oxygen, and that finishes off our tests for the water quality index.